Good evening, everyone. Okay, thank you for joining my class. Before we start, is everybody ready to learn? Sorry? Okay, that's very good. So, I can see all of you have logged in. Today we look at amplifiers, and our lesson title is transistor configurations. But before we go to that, I want us to recap what we did last time. I would like you to state the two types of transistors that we have. Who can state for us? Somebody to state any the two transistors that we have. That's very good. We have one bipolar junction transistors. Another one. Yes, Isabella. That's very good. Field effect transistors. Now let us look at what we'll do today. So in today's lesson we have two objectives to meet. That is, we should be able to define the term amplifier, and we should be able to outline the types of transistor configurations. Now let's see what an amplifier is. When we talk of an amplifier is an electronic device that increases the voltage, current, or power of a signal. So it means that if you input a signal of a low voltage or current, you'll be able to get the output which is of a higher level of voltage or current. And this one is done by multiplying the amount of the signal that you input with the gain of the transistor that is used in that amplifier. Now, this one happens depending on the configuration that we have used in a circuit. So transistors are connected in various ways to produce this amplification. That's why now we go to transistor configurations. Now, in transistor configurations, we know that the transistor has three terminals, and depending on how you connect these terminals produces three ways which we call configurations. So as a bipolar junction transistor, it is a three-terminal device. So there are basically three possible ways to connect within an electronic circuit, with one terminal being common on both either the input and the output. So the three configurations that we have are common base configuration, the common emitter configuration, and the common collector configuration. So for the common base configuration, it has a voltage gain, but there is no current gain. For the common emitter configuration, it has both current and voltage gains. And for the common collector configuration, it has current gain, but there is no voltage gain. In terms of the circuit, this is how the common base transistor configuration looks like. So if we look at the diagram, we have the base being common to the input and also to the output. So that one produces the common base transistor. But when we go to the common emitter transistor, here is the emitter. So the emitter is common in both the input and the output. And when we go to the common collector, the load is derived from the current which is at the base. So basically this one means that the emitter current is the sum of both the base current, this one, and the collector current. So at this point, the base current is moving in this direction and the collector current is moving in this direction. So the emitter current is equivalent to the sum of these two currents, which is the base current and the collector current. And also something to note is that when we get the ratio of the collector current and the base current is equivalent to the gain of a transistor. During amplification, if we have the transistor gain equivalent to 100, therefore, if we input a signal of, let's say, 10 milliamps, the output that we'll get will be 10 times the gain of the transistor, which means it is 10 times 100, and that is equivalent to 1000 milliamps. So you can see that the input is small, which is 10 milliamps, but now the output is 1000 milliamps, which is equivalent to 100 times 10. Now, I want to leave you with an assignment, which I'll collect when we meet next. And the assignment is outline 2 applications of a bipolar junction transistor. Outline 2 applications of a bipolar junction transistor. Now, let's summarize our lesson. I would like you to state the 3 configurations that we have. The 3 transistor configurations that we have. Who can state one? Yes, Jude? Sorry? Okay, that's very good. We have common base configuration. Yes, that's very nice. We have the common base. Another one? That's very good. We have common emitter. And the last one? That's very good, Isabella. We have the common collector. Thank you very much for attending this lesson, and I wish you a very nice evening. Thank you. You are free to leave.